All right, welcome everybody to the IPNSIG Academy for this month. This month we're going to be discussing interplanetary network architecture and governance. If we can go to the next slide, please. So just as background, as a way of getting into the subject before I turn it over to the panelists, I want to point out that we're now engaged in an enormous international endeavor going back to the moon, and with increased emphasis on missions to Mars and eventually sending humans to Mars as well. So to demonstrate how international this effort is, that will ultimately be international and interplanetary, it's worth looking at some of the efforts that are underway right now. This diagram is an exploded view of the Gateway, the small space station that we plan on putting in orbit around the moon during this decade. And the exploded view shows a number of different modules, starting with the power and propulsion element and halo elements that will be launched on the first flight to initiate it, but then contributions from Canada, Japan, and Europe are shown here as various modules, both expanding capacity and adding logistics capability. So as the Gateway fleshes out, and we see Orion, the crew vehicle, flying in on the lower right, and transferring crew through the Gateway to the human landing system that's shown on the lower left, we expect that Gateway will be not only an international hub, it will also be a node in the LunaNet network of networks on the moon, with both the US and Europe right now putting nodes on the Gateway that will be part of the cislunar communication, networking, and position, navigation, and timing, or PNT capabilities around the moon. Next. If we look at the after the early Artemis missions to prove out the Space Launch System, Artemis, and the Human Landing System, we will start building the Artemis Base Camp. And what you see here is in the background an inflatable international habitat, pressurized rover to complement the unpressurized rover in the foreground, and the beginning of mining and in situ resource utilization, in addition to scientific activities on the moon. Again, we expect international contributions for these surface capabilities and surface networking and communications to go along with that. This will also be part of interplanetary network activities. Next. In the past, we've seen in recent years, European Space Agency has proposed the Moon Village concept, and we see one possible depiction of that here. That's migrated right now to some activities going forward under the UN. So that continues to move forward and has taken root in ESA in terms of their Moonlight initiative, which will be expanding communication and navigation capabilities into the interplanetary network environment. Next. So that talks about some of the architecture elements that you can see or look forward to. But in terms of governance, we're much farther behind. That's much more nascent capability that we're just scratching the surface on. NASA, in order to start thinking about governance activities, has been developing the Artemis Accords that you see here as a way of starting to promote international norms of behavior in space, and working that with a lot of countries around the world. So rather than trying to scale Mount Everest and get a treaty through the United Nations, which is extremely difficult these days, too easy to veto, we're going for a more collegial approach that requires us to define principles that we plan to pursue, convince colleagues, other nations, to go along with us on those principles, and then we'll have to figure out what those principles translate into in terms of actual governance activities. So So out of the set of 9 principles that you see here, all based around the notion of peaceful practices in space, the one I'll focus on is interoperability. And that's a key one for us to think about in terms of interplanetary networking. If we're going to have communications, networking, rendezvous, proximity operations, docking, a variety of active movement of vehicles while things are going on, in addition to some of the principles that you see here, like emergency assistance. If you want to be able to come to the aid of a fellow astronaut from another nation, your emergency assistance capabilities better be the same, or you won't be able to render aid. So these are key principles that have direct bearing on what we're talking about for interplanetary networking. So next, what I need to do now is introduce our panelists. And to do that, I want to start with Kaneko Yasuke. Kaneko currently serves as the president of the Interplanetary Chapter of the Internet Society, or IPNSIG, which is an international nonprofit organization that envisions expanding networking to interplanetary space. Under his dedication, and along with the entire membership, in June 2022, the IPNSIG successfully became a standing chapter of the Internet Society, known as the Interplanetary Chapter, to promote its vision and to enhance the goals of ISOC. Since he assumed leadership in September 2020, he's been leading efforts toward creating a common vision, shaping the future of the interplanetary network, and promoting activities, including the establishment of 6 working groups and the publication of the strategy toward a solar system internet for humanity in July of 2021. With his engineering background in avionics and communications, he has about 20 years of experience in the space field. At the National Space Agency in Japan, or JAXA, he's contributed to the development and operations of the International Space Station, or ISS, including establishing a bidirectional communication link using the Internet protocol between ISS and the Japanese ground system. He also led the Japanese flight control team as flight director between 2009 and 10. From April 2020 to March 2022, he served at the Strategic Planning and Management Department of JAXA, where he led the overall coordination of JAXA's human spaceflight, space science, and exploration programs. Today, he serves as the Space Exploration Innovation Hub Center to promote research and development of innovative technology with non-space private sectors to enable future space exploration. The second panelist today will be Marc Blanchet. Marc is an internet network engineer from Quebec who contributed over the last 30 years to the engineering of new internet technologies such as IPv6, internationalized domain names, registration data access protocol, and delay-tolerant networking. He's authored or co-authored 17 RFCs in the IETF, co-chaired more than 15 IETF working groups. I don't know how you do that, Marc. That sounds impossible. Including the DTN working group, was member of the Internet Architecture Board, and has been Internet Assigned Numbers Authority Transition Working Group co-chair, under which he received the ICANN Leadership Award for his efforts there. Marc likes to keep his hands dirty by developing applications in various languages and platforms. Recently, he proposed and implemented ways to reuse internet protocols and applications over DTN networks in space. On his Fridays to give back, Marc volunteers in a local food bank and a homeless shelter. And third panelist today, Dr. Vint Cerf, who is the Vice President and Chief Internet Evangelist with Google. At Google, Vint contributes to global policy and business development and continued spread of the internet. Widely known as one of the fathers of the internet, he is the co-designer of the TCP/IP protocols and the architecture of the internet. He has served in executive positions at the Internet Society, the Internet Corporation for Assigned Names and Numbers, or ICANN, the American Registry for Internet Numbers, MCI, the Corporation for National Research Initiatives, and DARPA, as well as being on the faculty at Stanford University. Vince sat on the U.S. National Science Board. I have no idea how you sit on a whole science board. That's too many people to sit on. And is a visiting scientist at the Jet Propulsion Laboratory. He is a foreign member of the Royal Society and Swedish Academy of Engineering, a fellow of the IEEE, ACM, American Association for the Advancement of Science, the American Academy of Arts and Sciences, British Computer Society, worshipful companies in information technologists and stationers. You got to tell us about that one. And is a member of the National Academies of Engineering and Science. He is a recipient of numerous awards and commendations in connection with his work on the internet, including the U.S. Presidential Medal of Freedom, the U.S. National Medal of Technology, the Queen Elizabeth Prize for Engineering, the Prince of Asturias Award, the Japan Prize, the Charles Stark Draper Award, the ACM Turing Award, the Légion d'honneur, and 29 honorary degrees. And in his spare time, he climbs mountains, deep sea dives, is a test pilot and astronaut. Not really, I made that last part up, but I thought I had to pad his resume a bit. All right, with that introduction, I will turn it over to Kaneko to take it away.
All right, so thank you so much, Jim, and hi everyone, and welcome to the IPNSIG workshop. So today, our focus would be to have discussions on architecture and governance of the interplanetary network. So I want to start by addressing you with, why we're holding this workshop today. So as Jim said, at the moment, when we look around the globe, we're seeing many programs, including the government and space agencies and private sectors that are really endeavoring to extend communication capabilities off the planet to the moon and beyond. So the construct of what we call the interplanetary network is really starting to sail off. These are absolutely remarkable steps for humankind, but it also poses the question of whether if we can end up in a common interplanetary network like what it was for the terrestrial internet. So back in 2022, the IPNSIG formed a working group called the AWG, which is the Architecture and Governance Working Group, to study the technical and also the management aspects in order to achieve a common interplanetary network. We've also learned a lot from our past Academy speakers, and we've looked at their views very carefully as well. And architecture and governance could be a quite complex topic. So what we would like to do is to share our work progress so far, and we're really looking for inputs from you all. So please let us know if you have any comments, and we'd be happy to discuss. Okay. So adding a little bit more context in space exploration, in the mid-2020s, NASA and ESA is looking at implementing the lunar internet, so-called the LunaNet. The LunaNet is a set of cooperating networks providing interoperable communication and navigation services for users on and around the moon. So these things are actually happening and coming very close to us. And if we go a little bit farther into the 2050s, we might have a moon base, a Mars base, and many spacecrafts all connected with each other through an interplanetary network backbone. And what we would like to end up in is a common interplanetary network that will serve for multiple purposes and also used as a shared infrastructure. This is what we call the interplanetary network. So our vision is to have IPN as a common structure that benefits humanity because it leads to sustainable and resilient human and robotic activity, and also as innovation to emerge. And the key enabler to make this happen is to work toward a coherent architecture and to form a collaborative governance mechanism to support this network operation. So these are just labeled some of the examples of the private companies who are venturing into the space arena to extend communication capabilities into space. Just naming a few, there's a lot more endeavoring to push forward space communication out to space. So we've seen that the space agencies such as NASA and ESA and JAXA are bringing in their LunaNet assets to space, and so are the private companies. So the question is, could we achieve a common interplanetary internet in the end? And that's our core theme today. So I really love this chart, and to me, the current situation in space communication is kind of very analogical to the old days of the internet. And I'm hoping that the event is online today. Could you please speak a little bit around us?
Well, thank you. At the very last minute, Laura saved me with the correct link. I've been joining and rejoining and not getting any videos. So apologies for all of that. Those of you who are looking at this chart might appreciate two things. The first one is that the primitive internet consisted of three different networks. The ARPANET, which was started in 1969 or so, but concurrently with that, a mobile radio network and a packet satellite network were also implemented in order to emulate the situations that the military would find itself in a command and control environment. And ironically, of course, for space communications, radio and mobility are both essential. And so even though this was designed to be a terrestrial system, it certainly drove us in a direction that is not different from the situation we find ourselves on other planets or planetoids or moons. What this did not do, however, is deal with the parametric difference between delay and disruption tolerant networking over extremely long distances and variable delays, and the relatively short-term delays of the terrestrial environment. The picture on the right was 1994 celebration of the 25th anniversary of the internet. We wanted to demonstrate how primitive it all was. It took us a whole day to set up this chart, find the zucchinis and the yellow squash and string them all together for the Newsweek photographer. But we wanted to let people appreciate how primitive the technology was when we were first working on it. And you'll notice that there's a geek joke in the picture because this is ear to ear and mouth to mouth, but there's no mouth to ear connection anywhere in this picture. And we wanted the geeks to recognize that this design was never going to work because there was no mouth to ear connection at all. Nonetheless, this was early days exploration of what it meant to do computer communication in mobile and satellite-based environments. We've learned a lot since then, and we still need to learn more because the non-terrestrial environments are even more challenging than the internet was 50 years ago. And that's why, of course, we have an AWG in the first place, to understand both the technical problems and now also the policy problems, which are sure to arise as the network continues to grow.
Yeah, thank you, Vint. I really love this picture on the right, and we should probably take the same picture when we interconnect the three different networks in space. So that will be something amazing. Well, thank you very much. And moving on. So IPN governance is really a theme today, given these backgrounds. We think that the common IPN is the way to go. And the build of the IPN infrastructure is already starting. And we also want to learn from history. In the early stages of the internet, engineers and researchers pioneered the technology, which rapidly spread across the globe, and governance aspects had emerged after the spread of the technology. So for the internet, it's my understanding that we were more kind of responsive to deal with the various governance issues. But for the IPN, we want to learn from that as the new era of space exploration begins. So the term governance could be a quite tricky term, but we have defined it for the purpose of this study as the administration and management mechanisms. It's supporting institutions and their practices toward an open, accessible, and common interplanetary network that is built, operated, and used by the various entities. So we looked at this problem from the four major perspectives that you see here, which are the policy-making process and the open standard development and critical resource management, and also from a law and treaty perspective. So this is our wonderful working group members who contributed to this study, and is really an amazing team formed by many of the engineers in the space field from NASA and ESA and JEXA, and also from the private sector. We also invited Dr. Laura DeNardis, who's an expert in internet governance, and of course, Dr. Scott Pace, who was the executive secretary of the National Space Council during the Trump administration, and now at George Washington University. So at the working group, we started by framing what the core issue is. As the interplanetary network could be made up of multiple independent but interconnected networks that requires collaboration to function. So from an architectural perspective, how could the various networks, whether it could be a space agency's network, a private sector's network, or an academic network, how could these networks, these heterogeneous network, how could they work as a whole? Was the big question. And the governance question is what institutions play what role to support the operation of the IPN, or what do we need to govern anyway, and what governance model should we employ? These were kind of the starting point questions that we asked upon ourselves. And we also noticed that there are several viewpoints and considerations when looking at this problem. On the architectural side, we said that the architecture could be a mix of IP and also bundled protocol. And that said, we would need to have a kind of a workable strategy to deploy IP in space. Or what about routing methods in order to send bundles that are at interplanetary distances? And on governance, Laura DeNardis had given us some outstanding views during her talk at the previous academy. She pointed out the four angles that you see on the right-hand side, which really informed us on contemplating the structures of the IPN governance. And we kind of took them very seriously during our study. So here I would like to briefly touch upon what's ahead of us in the architecture, the IPN architecture. So we try to look toward the future and illustrate what's coming in the next decade or so. So if you look at the image on the far left, I know this is a really busy chart, but please scan the left-hand side, which is our current state. Government and space agencies sustain their own backbone using their own funds, and some of the commercial nodes are using that backbone. And in the not too distant future, governments and space agencies will start funding to commercial providers so that the governments can then become a customer in the end of that commercial provider's service. And in the far right diagram, which could be in the next 10 or 15 years from now, commercial services could run on their own, and everyone basically becomes a user of that commercial backbone. So we think this is one conceivable scenario of the evolution of the IPN. And another conceivable scenario is that deployment of IP networks in space. And Mark is going to walk us through on these prospects and how we want to deal with IP in space. So Mark, if you're ready, can you kick us off here?
Thank you, Kaneko. Kaneko-san. I'm really honored here to be part of this panel. As my shirt says, BP is not IP. That design is from Jorge Amodio. The idea here is that we shall have a mix of, in the space, a mix of bundled protocol networks blended with IP networks, and IP networks being on planetary bodies. And in some ways, what those IP networks will be IP isolated, in a sense that the shall not have IP reachability between the different planetary body, but they will be linked through BP bundled protocol, as shown on the slide here. For that reason, we would like to show you a few of the considerations that we've been working on related to the IP itself, IP deployment. For example, the IP networks may proliferate in spacecraft and on planet and moons, and spacecraft being in transit. So the considerations of transiting devices in space is also important here. We recommend the use of non-overlapping address space because that enables the architecture of the space networks, even if the IP network are isolated, to be future-proof, in a sense that if there is some connectivity, especially for the transit devices, vehicles, that enables us to not have any problem in the future for network address translation or unreachability in terms of network management. We don't want to start renumbering or changing addresses in space. This is already difficult on Earth internet. We don't want to do this in space. And for that reason, to be future-proof and to enable non-overlapping address space, we recommend using IPv6, as this is the only way to get proper address space. And IPv6 will give us additional features not described here, but such as the ability to have multiple addresses on the same interface and manage that clearly, and additional features such as prefix delegation and stuff like that. Next slide. Again, IP usage is a very conceivable scenario. It has been planned in the both ESA and NASA architectures for Moon and Mars. So IP is very a viable solution to be used on the planetary bodies. And the current plan is to use Wi-Fi and 5G layer 2 networking. Next slide. So the approach again is to extend the IPv6 address space. That enables us two-way reachability compared to an added v4, avoids any future conflicts or address leaks, and leverage existing IP management systems for organic transition. In a planetary body IP network, most likely there will be multiple networks owned and managed by different organizations. And to enable enough isolation between those networks so that one network would not, disturb the other one, and to have some policies, policy-based routing protocol, then BGP is the right engine, even if BGP is able to scale to, multiple millions of routes that would not be on a planetary body, at least for a foreseeable future. The BGP enables policy-based and isolation that would warrant correct stability on the planetary body IP network. If we use BGP, then we would need ASN numbers. And again, for the same reason as the IP addresses, we must use non-overlapping ASN numbering space so that we're really clean in terms of design. If we use IP nodes, then we shall use domain names, because domain names really completely embedded into IP stacks and applications, and also naming enables easier network management and in general. However, as we all know, and it's been one of the design criteria to create bundled protocol, is we're not going to do any DNS resolution over bundled protocol or over space links. Here, domain names will be only local to the planetary body, so really a local DNS system. We may define binding between our DNS hierarchy and may not, but all this will be require careful design. DNS will also enables us to provide service discovery of DNS services for the IP nodes and applications. Again, same concept, which is non-overlapping naming space must be used. So again, if we have any leak or any connectivity by some means later on, non-overlapping naming space as non-overlapping IP addresses will be safer. And again, we will be leveraging what we have right now. Next slide. So our challenge, and I think Vint in the next slide will actually provide us just a few of examples of challenges. That is far from done, but there's some good architecture and working work on this, and testbed being planned. Is really our challenge is how to properly combine the bundled protocol and the IP internet protocol together on the moon, on Mars, and in transit to other planetary bodies. We are currently working on examples such as email and HTTP and media over a bundled protocol to link those two network layer together. And for that reason, we would require application protocol standards to be put forward so that all, to achieve interoperability in space. I think that's the last slide, and I'm going for Vint to give us some, to remind us of challenges in space for IP networks.
So thank you very much, Mark. And I just want to tell everybody that Mark and I and others have been spending a great deal of time thinking our way through what it means to have both the bundle protocol in place and also the TCP/IP or quick over UDP running in specific locations, whether it's a planetary base or a spacecraft or something on an asteroid. We think that the pressure of utility and history will cause some IP capabilities to be present together with the bundle protocol system. I wanted to draw attention to something that did not get mentioned earlier, and I wanted to distinguish between joint networks and joined networks. The joined networks is the internet model, a collection of networks, a network of networks, each network capable of running independently, and having management boundaries, for example, and common standards for routing and other functionality. But a joint network might be a single network, but which is operated by, or in some ways built on a cooperative basis among multiple parties. And although we haven't shown or illustrated the joint network notion, I am pretty convinced that some of the bundle protocol implementations will involve multiple parties who have agreed to contribute resources to a single network, a single bundle protocol-based network, even though there are multiple parties involved. And I think it's important to recognize that we will have that management structure in addition to a network which is operated by a single entity and has a well-defined boundary as the autonomous systems of the internet have. So we see the bundle protocol again as being the fundamental backbone of the interplanetary or solar system internet. But the V6 networks, I think, may proliferate out of sheer utility in the spacecraft and in various of the bases and laboratories that are on the planets and asteroids and moons. We're still not, I am not sure anyway, let me not blame anyone else, about what it's going to be like to run a V6 network remotely, as opposed to having somebody there to handle technical conditions. But we have learned in the bundle protocol environment, thanks to Ed Burain and others, that there are ways of operating in high latency environments that do not support a kind of interactive network management protocol. And so somehow we're going to have to figure out how to manage a remote IP network, I think. And that's going to take some work. It's also very important to recognize that when Mark mentions HTTP, he's not trying to say, oh, by the way, we're going to try to run a typical interactive cloud-based web application remotely through the bundle protocol, because that too, as you all know, is a very chatty kind of an interface. But there are applications that could use the basic bundle protocol HTTP layer to put files or pull files or to do other kinds of relatively non-interactive things. And that's what the HTTP support would be used for initially. There's still an open question in my mind about managing the V6 addresses spaces used in these various non-terrestrial environments. We don't know whether we need a new RIR or whether an existing one could perform that function. Another related issue is whether DNS is needed for more than just mapping of domain names to IP addresses. I still harbor a belief that the mapping of a domain name into a bundle ID may turn out to be useful as well. And Mark and I are arm wrestling with each other over that case. In any event, having bundle-aware application layer gateways is what Mark has been working hard on for email and HTTP. And I've been speculating that content distribution might also be done using the bundle protocol as the basic transport mechanism, but having very local distribution done from the content distribution system that's co-located with a local internet implementation. And I think I repeated myself here with regard to the RIR registries and registrar functions that will be needed. But we will, from the governance point of view, have to think our way through whether we need analogs of those for space-based applications, not only to manage the local IP networks, which we anticipate will be in use, but also to deal with analogs in the bundle protocol space where these kinds of mappings and registrations are needed. And of course, there's the last bullet says there are probably other things we haven't thought of, but that's why this is such an important area of research. I'll turn this back over to Kaneko.
Yeah, thank you very much, Vint. And under the subtitles, it says, as chair of the leadership panel of the Internet Governance Forum. So those were views from Vint from that position. Thank you. This page kind of talks about the items that would require management to support the development and operation of the IPN. We have critical resources such as IP and domain names. These are all parameters which has a limitation in its capacity. So we need to have some mechanism to allocate these resources. Those could be spectrums and node numbers and IP addresses. These are the things that fall into this category. And we also need to think about the universal standard that becomes the foundational basis of the infrastructure. Those may include time standards, coordinate system, that's the physical ones, and many technical particle standards, including BP. So at a high level, we thought these could be kind of the top list that requires management for the IPN. So heading on to some of the governance side of the discussion. So these were really the fantastic views provided by Laura, which are called the anticipatory governance questions that really gave us the viewpoints for us to contemplate on IPN governance. You don't have to read it right now. I'll just go through them one by one. Okay, so the first one was about unique space challenges. So space is undoubtedly a unique environment with space debris flying around. There are natural disruptions like solar flares and radiation, and things could break. But at the same time, we need to live with many constraints. Spacecrafts are at interplanetary distances. Power generation could be limited, and it's likely that we don't have an onboard crew. So maintenance could be a quite challenge in space. So when we reflect upon these aspects, the IPN would require a greater autonomy to compensate with such environment in space. And those were our observation on this angle. And moving on, the second point was on how space governance, law and treaty could effectuate IPN governance. So today, basically space activities are all considered to be a state activity per the Outer Space Treaty, which was adopted by the UN General Assembly in 1967. It's the states that owe responsibility to assure the behavior provided in that treaty for any given mission of that country, even if it's a private sector's activity. So, but we did not see any fundamental barriers from a law and treaty perspective at the moment toward the IPN. But since the OST does not take into account the expansion of commercial activities in space, one might expect that potential clashes could occur between public and private interest, is our observation for now. And the third point was on terrestrial internet governance applicability. Critical resource distribution of numbers and spectrum is really important. And we think that leveraging the existing management mechanisms that already exist today would be one practical approach to be taken for the IPN as well. So we identify 5 or 6 of critical resources. So for spectrum, ITU-R allocates frequencies today to certain services, and each state would do the authorization for that use. And we think this mechanism could be extended to frequencies in space, specifically beyond the geostationary orbit. And it's my understanding that there may be some policy discussions on the allocation of the spectrums to support lunar communications toward the WRC in 2027. And BP node numbers, of course, are critical resources. The IETF is, if I understand this correctly, the IETF is recommending IANA to serve as the master depot. And under that would be the allocators who would allocate the node numbers. So this could be kind of very similar to the IP address allocation mechanisms through the IANA function and the RIRs in the internet world. And at the bottom, for LNSP numbers or region IDs, this is still in flux, but if we were to have a kind of a similar concept like autonomous system numbers for LunaNet, that would entail some kind of management mechanisms to number the network. So we thought that could happen. So we've identified that as one of the resources. And speaking about IP addresses and autonomous system numbers and domain names, basically we think, as of today, we think that the current internet regime using the IANA and the RIR model could be used to allocate the numbers and names for space as well. And this is just a picture illustration of what I've just talked about. The blue one on the left-hand side is the IP, ASN, and domain names. We have the setup of the INF function and the RIRs, and our thought is that the INF function allocates IPs for space use and also for ASN and domain names. And for BP numbers, basically the same, INF function at the top and allocators underneath, and the allocators will allocate the numbers for whatever purpose they wish. And for Spectrum, ITU, and they allocate services for space use is our expectation. So next is about open standards, which is no need to say, but really critical. By having open standards, it will allow coherence in the architecture, and it's important that we pursue harmonization of standards as much as possible to avoid any fragmentation of the IPN infrastructure. And so there's the IETF and CCSDS already working on standardization of bundled protocols, and we think this effort should be continued. For time and coordinates, these are extremely important parameters, needs to be governed, but the question is, in which standard do we operate, and who controls that? It's my understanding that these topics are being addressed in other forums, so the IPNSIG kind of deferred that to other groups, but we identified these as critical items that requires management for the operation of the IPN. So the fourth angle from Laura was some of the anticipated flashpoints based on the lessons from the internet that would inform the structures of the IPN governance. There were many points here, but for today, I would just want to focus on the yellow highlighted one, which is tensions will exist between multilateral versus multi-stakeholder models. So again, so we talked about space activity being a nation-state activity. So it's based on a sovereignty kind of model, as opposed to the internet taking the multi-stakeholder approach. So basically, whether in the internet, whether if it's a nation state or a private sector or the general public, basically everyone has a say for the internet. And here's a interesting equation to simplify the problem. So space times internet is interplanetary internet, but space governance is based on sovereignty, and internet governance is multi-stakeholder. So what is the governance model for the interplanetary network is the question we are discussing right now. And we are reaching the end, but I do have 2 more slides. So we talked about this several times at the working group, and we looked at the internet, and it did not dictate anything on its configuration or business models. The infrastructure grew naturally because we had open standards that allowed autonomy, which allowed the growth of networks. And also policy decisions are made amongst multi-stakeholders in the internet world. And that has really proven to us that it's really a sustainable approach to support such a foundational infrastructure. So what we have drawn together at this point is that inheriting the internet model, which is the multi-stakeholder model, would be one of the most sustainable approach to support the long-term activities in space as well. So this would be my final chart. So in summary, our preliminary assessment so far is that we take the multi-stakeholder approach for IPN, for policy-making processes, leverage the internet model, and to ensure that no single entity controls that infrastructure. For a critical resource, we should also inherit and make use of the existing internet management mechanisms such as the INA function and the ITU, as these mechanisms has really matured over the course of time and has a long history in its operations. And we would need to advocate for open standards because that's the key to enable autonomy and scalability in the architecture. And of course, we will need to still live within the box of the law and treaty. There should be no fundamental barriers at the moment, but it's conceivable that tensions could exist between the sovereignty model in space and the multi-stakeholder approach of the interplanetary network. And I think that concludes my presentation. I think that was a lot of information, but happy to discuss. So Jim, I'm giving it back to you.
All right, thank you, Kaneko and Vint and Mark. That was a very brief tour of everything that we've been working on in terms of architecture and governance, but a great survey of all of the things that are involved that we're aware of at this time. So there should be plenty of ammunition for questions there. We have several already identified in the Q&A panel, so I'm going to go to the Q&A panel and start with the questions that have already been posted. The first one was by Nabil Yassin.
Jim, it's Vince Cerf. Could I interrupt you for just a moment?
Sure.
I apologize for that. I had hoped to have just a moment before you started the Q&A to make a couple of other observations, which makes the challenge before us even more complicated. The model that we used to have is that going into space was a national effort. And what has happened in the interim is that the commercialization of lift capacity in particular, and now the commercialization of other potential services that NASA is inviting the private sector to offer on the moon in the Artemis missions, changes the equation pretty significantly. In particular, a country which would not normally have an active space program can suddenly essentially purchase lift capacity or get piggyback capability in order to engage in space operations without necessarily having its own lift capability. And that, plus the fact that the private sector also has access to these same commercial services to get into space. And as you can see, as some of you who are following this know that there are companies already forming that are trying to offer landing services onto the moon, for example, either from Gateway or literally from Earth. And so what this means is that the mix of participants in space enterprise is much, much richer now than it ever was in the past. And so it makes things somewhat more complicated in the same way that companies like Google, my company, are multinational in scope. We have nexus in many different countries in the world, and somehow we have to be able to operate as a private sector entity, and yet we are under the guidance and legal frameworks of national governments. So all of the questions that Kaneko and Jim and others are asking are colored by this rich opportunity for so many parties to become active in the space uses of space and exploration of space. Some of the comments in the chat, not the questions, but the comments in the chat, were raising questions about engagement with the private sector. I would say that there is ample opportunity for the private sector to become very active in the programs at IPNSIG. So sorry to go on, but those seem like points worth your hearing. And now I guess it's time for Jim to go let the people with the questions ask the questions so we can try to get them some answers.
Okay, thanks, Vint. And we will circle around to that issue again. As you mentioned, there are some comments and questions in the chat that I think we can come back to after we deal with the questions that have been posted so far. So I think I'll start by reading the question and throwing it open to the panelists to respond. And then sometimes I'll take a shot at adding to it myself. So the first question from Nabil Yassin is, is ITU and other intergovernmental organizations playing a role in this IPN internet?
So it's been one answer to that question is yes, particularly ITU-R on the radio side. There's an open question that we will ask Doreen about, and that has to do with laser frequencies as opposed to radio frequencies, or laser wavelengths, if you like. I'm not sure that ITU-R currently does anything about that, and yet we will need to have some ability to resolve potential conflicts in the use of laser wavelengths. So that's a very important open question.
Correct. Yeah, the ITU-R currently only provides radio regulations up to 300 gigahertz, which doesn't come close to the 190 terahertz range that we see in optical frequencies. So they are not regulating optical at this point, which has got good sides as well as bad sides. Kaneko, Mark, anything to add there?
No, nothing to add. We're really happy to hear from ITU Secretary General next month for the IPNSIG Academy, and we'll see how ITU would ITU would engage in the IPN internet. So that's all from me.
Okay, from my standpoint, with respect to NASA, we are strongly participating in international spectrum management in a multi-step process. As a federal agency within the U.S. government, we follow the U.S. government process where there are two federal agencies that regulate spectrum within the U.S., the National Telecommunication and Information Administration, or NTIA, that regulates government use of spectrum, and the Federal Communications Commission that regulates non-government use. And those two agencies then cooperate with the State Department in order to assemble U.S. government formal position when we go to the ITU. So NASA acts as part of the federal government feeding into the NTIA. And has our position within, one of many agencies that feed into that. We also work directly at the international level, as on the chart that Kaneko was going over with that showed ITU on the right-hand side and the Space Frequency Coordination Group, the SFCG. That is where the civil space agencies come together to coordinate. And right now, that's where the spectrum issues are being resolved in terms of the spectrum being proposed and designed right now for LunaNet. So we've been working with SFCG to define issues, including how do we deal with the shielded zone of the moon on the far side to protect it for radio astronomy and yet have all the communication, networking, navigation services that we need. How do we deal with cellular telephony, which is in the process of going through a formal decision process within NASA on whether we adopt cellular technology, primarily, or at least initially, for surface-to-surface use, but may branch out from there. And so there's a lot of that goes on. Those are the spectrum questions regarding those applications right now are coordinated through SFCG which is the first step in the international process where the international spacefaring countries come together. And then it's elevated to the ITU and through various forums that they run, ultimately running up to the World Radio Communication Conference that's coming up this fall to get these translated into radio regulations that apply to everybody. So we are working those processes very strongly at a national and international level, and the whole and everybody cooperates, right? As far as I know, all of the countries of the world cooperate in the ITU-R in promoting those radio regulations. So expect to see all of the spectrum issues answered there. All right, let's move on to the next question. Dan York asks, on an early slide, there were a number of companies mentioned as being active in space these days. Kaneko, if we're flipping charts, can we go back to your slide, I think, on their list of companies? Are any of these companies involved in this work around defining an IPN? That's the one.
Yeah, thank you. I think this is chart, and this is really just an example of some of the companies who are supporting space communications, and not specifically for the interplanetary internet yet. Those include some companies who are endeavoring to put LunaNet assets or trying to support from the ground side. But this is kind of a picture of who's coming to the space communication arena, but not necessarily for the interplanetary internet. I know that NASA and ESA is working with some of the commercial companies, but I'm not sure those are included in here in this chart. Maybe Jim, you can add some stuff here.
Yeah, Vint, Mark, do you want to add anything?
I was just going to point out that some of these are not necessarily volunteers in a funny way. Google Cloud, Microsoft Cloud, and AWS clouds are actually hosting, if I've understood correctly, implementations of the bundle protocol, but it's not because those companies are pursuing it. It's because their users are pursuing the use of their cloud services in order to do some of the tests and experiments that our project working group is undertaking. At some point, though, I hope that we will gain enough visibility that companies like the ones that are listed here will want to be part of the IPNSIG discussions, if only to either influence or learn what it is that we are learning about both the technical side and the governance side of interplanetary networking.
Okay, Mark?
Yeah, I actually wrote something in the chat which has essentially, listing all space companies that are or may be involved would be a challenging task. So I think we should think of this slide as a list of a short list, but no real judgment on who does what, when, where.
Yeah, and I just recall that KDDI, the one on the right-hand side, is a major Japanese telco company, and they do have business plans to deploy cellular networks on the lunar surface, and I think they have the pretty concrete plans for that. So I would say that KDDI is one of the companies from Japan that could participate in the interplanetary network.
All right, I'll add my 2 cents. There are a couple of the companies that are shown that are actively participating. For example, Nokia was awarded a contract to do a demonstration flight that's on an upcoming CLPS mission, the Commercial Lunar Payload Services program, that's going to put a payload on the moon, where the lander will act as the base station. A small rover will be released that will run around and act as the user equipment, and it will demonstrate a 4G LTE link in a variety of different conditions at different ranges on the lunar surface. So that will literally be our first experiment in using 4G cellular capability on the moon. And Nokia has publicly announced plans to follow that up with the ability to put cellular technology on the moon, and that's not just something that NASA is paying for, it's something that Nokia is investing in as a future capability. Surrey Satellite from England has already announced plans to put a Pathfinder orbiter in the orbit around the moon to provide communication services. And from their early Pathfinder position, they're being influenced by LunaNet and are coming increasingly into the LunaNet sphere. But then I run into the problem. This is the good news and the bad news. The good news is that both NASA and ESA have recently released procurement requests to industry to purchase commercial lunar communication and navigation services. And so proposals have been received by both agencies. Both agencies are in the process of evaluating the proposals, and we're in a blackout period, and I absolutely cannot say anything about what's going on in the source selection process there. Wait until you read that in the news when the contract awards are announced. But the good news really is that we are on a bilateral basis initially implementing LunaNet interoperability with both ESA and NASA having collaborated on producing the LunaNet interoperability specification, which was part of both of those procurement packages. And so the commercial services that both agencies are procuring are expected to be interoperable and include network layer services. So yes, we do expect to implement interplanetary network capabilities, starting with the lunar environment and LunaNet. Some of the others here have contracts with NASA on a different program. We have a commercial services program that's looking at ultimately replacing our current tracking and data relay satellite that's in GEO and provides service to NASA missions as well as partner missions in LEO to MEO kinds of orbits. And we're expecting to replace TDRS with commercial service. So we have contracts with 6 commercial satellite communication companies right now to demonstrate their ability to provide space relay capabilities from satellites that they're putting up or have up in GEO to MEO altitudes, and expecting to provide service to MEO to LEO spacecraft. And so that's under evaluation. Ultimately, you can look forward to network layer services being run over those commercial providers as well. So that includes a couple of, like on the chart, like SES and SpaceX. And then we're in discussions with other space agencies, and they are in discussion with some of the companies in their countries. So there are a lot more companies than are on the list that are in the hunt for this. Oh, one other thing I'll mention: the CLPS contract that NASA let that has awarded 14 contracts to commercial providers to deliver payloads to the lunar surface. So this is a transportation contract, and did not include requirements for communications. However, the transportation service includes one of the task order options includes the ability to deliver payloads to the far side of the moon. And with the moon being tidally locked to the Earth, you can't communicate to the far side except by some kind of a lunar relay. And so several of the CLPS providers have announced that they are intending to provide lunar relay capabilities to meet their obligations on the CLPS program, and they are looking at and evaluating adopting the LunaNet approach. So we've got another opportunity there to influence commercial industry that isn't under contract for specifically required to meet LunaNet requirements. But we are trying to both influence industry and other participants to adopt an interplanetary networking strategy. All right, let's move on to the third question. Scott Johnson asks, regarding spectrum, is there any regulation on free space laser, or are we at the Tesla Marconi stage with that?
I think we got an answer already. The ITUR does not deal with laser comms. If there is any discussion going on, it must be among the space agencies themselves.
Yeah, it is. So my knowledge of that is that we on the NASA side are largely pursuing optical frequencies that are the same frequencies that are used in optical fiber. And part of the reason for that is the industry behind that, right? If you're looking for optoelectronic parts, there's a big industry out there that already provides parts in those wavelengths. The other reason is that when you're interfacing free space optical links to fiber optic wired links, if you're using the same wavelengths and some of the same protocols, you're basically plug compatible between free space and fiber optic capabilities. So that's a part of that strategy. The other, there are a set of standards related to fiber wavelengths, and we are using those for the free space frequency. So we're centered around 1550 nanometers, the same band regime that's being used for fiber optics. But it's not the only one. ESA, for example, and DLR, the German space agency, have been pursuing 1064 nanometers as a different wavelength. And that gives us interoperability problems. But the European companies that are investing in this technology have already concluded that the space agencies may dig in and resist change, but the companies just want to put up optical capability and sell units and make money. So they'd rather switch than fight. So we're seeing a steady progression, or I'll say a switching in progress, right? Aligning more with 1550. By the way, 1550 has one other advantage in space, in that it is relatively eye safe. It's about 20 times more eye safe for a free space optical link at 1550 than 1064 or 890, a couple of the other frequencies that are used. NASA already went through a process, a review process on safety with the FAA in the United States for aviation, because if we got lasers on the ground that are shining up through the atmosphere, they have the risk of illuminating aircraft and potentially interfering with pilot operations. So we want to make sure that human safety is a key factor, and that's another reason for adopting 1550. So there is surprisingly quite a bit of alignment on optical wavelengths without putting it under the ITU.
It's Vint. I just wanted to make one other observation, Jim. One of the new developments in optical fiber is what's called hollow core fiber. And in that particular design, a much broader range of wavelengths are workable, because they're not going through the glass. They're actually going through what in effect is atmosphere. So that might induce a broader range of lasing equipment than what we typically get today with erbium doped or otherwise doped fiber.
Good point. All right, let's move on to the next question. Jorge Amodio asks, how do you plan to engage the private/commercial sector into the conversation?
Well, it's Vint. I think we are very close to that for several reasons. First of all, because of the NASA and other agencies engaging directly with the private sector, the CLIPS program, for example, they're already being drawn into the discussions anyway of the Artemis and Gateway missions and the counterparts in the other space agencies. But I think that we also have an opportunity to draw attention to that commercial sector, to the work that's going on in the IPNSIG, and invite them to become part of the discussion. I would hope as our work becomes more visible, that will attract more private sector interest.
Yeah, and just to add a little bit, when we talked about this chart while my presentation, I think we are kind of heading toward the transitional phase right now, where we are trying to purchase commercial provider service for the LunaNet. And I think NASA and other space agencies are making solicitations from the industry to provide comments to the requirement of the LunaNet spec. So I think that's kind of one process of involving the private sector to eventually purchase those services in the end.
It's Vint again, if you don't mind. One other thing I am a little worried about with regard to managing more conventional terrestrial communications technologies like cellular on the moon, we may very well be going down a path which might work okay in the cislunar space, but it might not work very well on Mars. And the reason being, we might not have operators on Mars capable of running those conventional communication systems using conventional network management tools, and except if they actually have people on the planet to do that. So the remote operation is a big issue, and that's one of the reasons I'm concerned that the commercialization effort at NASA may not necessarily help us in terms of staging in preparation for Mars operation, which is far more distant and therefore doesn't admit of the kind of local low delay interactions that might work successfully for management of, say, an LTE system on the moon.
Okay, Mark?
Nothing to add. I think the more we get people involved, including commercial, it's all good.
Okay. Again, from a NASA perspective, we're obviously in the thick of working on this right now. So I can tell you part of this is, we think we have a preliminary answer from a contractual basis where we're expecting to make multiple awards on the RFP that's active right now. And then we'll see what coordination can occur and how much genuine interoperability we can get among the several companies that we contract with. And in turn, we'll be testing against ESA and their contractor or contractors to demonstrate not only intercompany, but international intercompany interoperability. And then the question that's still on the table and still largely unanswered is how does commercial industry participate directly instead of via government contracts? We are trying to anticipate that there will be a transition from industry treated as compliant with government requirements to industry as a direct participant and contributor to the whole thing, right? We're expecting that, like the internet, commercial space industry will become a direct player and will grow a lot faster than space agencies, and eventually, we'll be asking them what standard to follow, not telling them or building it ourselves. But it's not at all clear how that plays out. It's a very pertinent question and very much a subject of discussion right now. Moving on, Pablo Dori asks, will there be any interaction between 3GPP standards, 6G incorporating non-terrestrial networks, with those defined and to be defined for IPN?
So it's Vint. There is a speculative answer to that, and it might be yes. And the reason that it's speculative, of course, is that we don't yet know what 6G is in its final form. But there is this notion in 6G and maybe even 5G of an edge computing capability, base stations with computational capacity. It's entirely conceivable that such a system could be running the bundle protocols at the edge and therefore become participant over the more conventional radio transmissions of a typical mobile system. And so it's feasible, and it might even turn out to be easier to do because the edge computing element is really in user space as opposed to down in the operating system. So that's an easier place in which to try things out and to populate new software. So those architectures might actually admit of running bungle protocol on top of a more conventional mobile transit.
Mark Conoco?
Nope, nothing to add.
Nothing good.
All right. On the NASA side, right now we are looking at, as I say, the change request to formally add 3GPP capability for the lunar surface is in the process of working its way through the Artemis program right now. My bet is that we will adopt it. People have been asking me this for years. I've been telling people for years, when you pack for the moon, take your cell phone. So I would expect that the answer will be yes, and we'll obviously need a gateway between the 3GPP domain and the non-3GP domain, but we have that in the terrestrial environment as well. So I think that the answer to that is yes. Next question, Nabil Yassin asks, do you think China, Russia, and maybe others will join this IPN network, or will they plan to deploy their own networks and protocols?
I'm not aware of any concrete plans from China or Russia. I do have information about general lunar activities, but not specific to interplanetary network. But I think what's important is for us to remember is that we need to have architecture that is extendable to other heterogeneous networks. So I think we should have the flexibility to interconnect with other different networks. So, and I think when we look at the interplanetary network, the one we set up on the moon or around the moon would become some kind of a basis for a further evolution of the IPN. So I think it's important that we remember that we stay open and stay interoperable with other different heterogeneous networks.
Well, it's been, there's an interesting question about China and Russia. They generally like to go their own way in many ways. One interesting question is whether they would go so far on their own path that they wouldn't coordinate allocation of IPv6 addresses, even if they were using IPv6. And we would hope that somehow they'd be persuaded that some of the proposals that we've been making in order to make the IPN work would be relevant and acceptable to them as well. Even if they start out completely independently, it would be nice if, as Kaneko says, that they would end up being at least compatible with the IPN and therefore could become part of it if they chose to do so.
I agree. Go ahead, Mark.
I was just going to add that if on the IP side, you know, just as the slide we have in front of us is that we could imagine some peering points where networks could be connected with, you know, whatever policies. So, you know, BGP, AS numbers and stuff. So it would be just fine if they come later and then, you know, connect, right? So we're kind of building a network of networks as we have done, you know, like Vint has done on the internet, right? So if they're not participating right now, they may be joining later and no issue.
Yeah, I think we know partial answer. We know China and Russia actively participate in ITU, so they are part of the spectrum management process at the international level and comply with radio regulations and have their own national radio regulation process in addition to the international. They they work with CCSDS. They adopt CCSDS standards in space. They certainly have networking capabilities terrestrially, and I believe they use networking on board. Russia, Roscosmos, still a very active full partner with NASA, ESA, JAXA, and CSA on the International Space Station, and so we have cooperative activities still going on there, and so we know that they use a lot of the same technology, the same standards, the same spectrum allocations. So I suspect that that they're somewhere between 80 to 99% potentially capable of being interoperable, and the question comes down then more to national intentions. Do they decide to participate or not? I think if they decide to participate, they don't have a big gap to cover in order to participate. All right, Dan York asks a related question. China and Russia have both announced their own programs for lunar activity independently and together. Are people from those countries involved with discussions around IPN, or could we wind up seeing separate fragmented communication networks in space or on planets?
Well, it's certainly possible for, it's Vindian, possible for them to design and build something which is not interoperable. They are members of CCSDS. They have access to all of the standards that we've developed. They have access to the IETF. So there's nothing stopping them from being both aware of and choosing to build things that are compatible. And I think if they're looking towards the future, they may very well decide they want to be compatible for the same reason that Russia and China have not separated themselves from the rest of the internet. They see it as having utility, even though they constrain in various ways the ability of their citizens to make use of the internet resources.
Yeah, I agree. I think I provided a partial answer to this, but I think there will be within shooting distance of having interoperability if they choose to do so. One of the organizations that NASA participates in is called the Interagency Operations Advisory Group, or IOAG, and it's where the space agents, the civil space agencies, work together on interoperability and the ability to cross support each other. So many of our missions are international in nature now that communication support can be provided by one agency for another agency's spacecraft and vice versa, or spacecraft can get support from multiple agencies on a particular mission. To date, CNSA, the China National Space Agency, Roscosmos, still remain members of that organization as well as CCSDS, but they haven't been actively participating for the last couple of years. I gave a presentation at the Space Ops conference a couple of months ago in Dubai, and mentioned that they weren't participating, but they would be welcome back if they came back and resumed membership. And I was approached by a member of the Russian Academy of Sciences after my presentation, who said, I didn't realize that Russia wasn't participating in the IOAG. I'm going to go home and make a recommendation that Roscosmos resume participation. So, you know, you get little hints like this at conferences and places where we have some limited communication that that there may be some upper level national political reason for not cooperating, but at a working level, the political reason that prevents them from cooperating kind of boils away, and you get down to engineering, and then we're willing to cooperate.
Right. We're officially at time, but maybe we can squeeze in Oscar's last question.
Yes. Oscar Garcia asks, Jim, as I see the companies are acting for now as contractors, but besides mining and eventually tourism, what other possible industries do you see in space?
Well, the obvious one is communications, because
Yeah.
there's already clear evidence of that. But I think tourism will also turn out to be something that we'll see earlier than you might have expected. We're already seeing it. We're seeing people taking suborbital flights. We're seeing people willing to pay substantial sums of money for an orbital flight or to go and visit the International Space Station. So that's something we can anticipate over time. And perhaps eventually that will become actually affordable, which today it really isn't, except for some particularly wealthy people.
Yeah, I think the industries that you're going to see being initiated at the beginning are going to tend to be infrastructure and utility type industries, ones that are ubiquitous on the Earth and need the same kind of ubiquity in space. Communications, power, navigation services, fuel, right? Fuel depot in space or on the surface, followed by mining, right? So if mining on the moon can produce water, then water is a depot commodity. Refined aluminum extracted from regolith, likely to be another commodity. So, utilities and basic infrastructure type companies I think are the first ones that are going to occur, and it'll expand from there.
I can hardly wait to see the first Ferengi gas station in orbit around Earth.
Got to follow those rules of acquisition. All right, we have, I believe, answered all of the questions posted to the Q&A. I think we have also run out of time. So that brings us to the conclusion of this Academy session. I want to thank our panelists today, Vint Cerf, Mark Blanchet, Yusuke Kanako, and thank you very much for your participation and expertise in this. You represent a large slice of broader expertise that's been working on this for quite a while now. And for the participants, thank you for attending, and thank you for not just listening, but keeping the chat active and asking those questions. Following the presentation tonight, the Academy materials will be posted at our website, ipnsig.org/events. You can address any additional questions to our secretariat at ipnsig.org. And future meetings that are coming up on the next slide. It's already been mentioned, but Secretary General of the ITU, Doreen Bogdan-Martin, will be the subject of the next Academy on June 28th. And then several people are coming up in July, August, and September with the dates not yet fixed, but Paul Toomey, former ICANN CEO, Preston Marshall, former DARPA program manager, talking about 5G, 6G technology, Roberto Gaetano of Eurodig, lessons from the internet. All of these guys will be talking about their background and how that can be applied to interplanetary networking. And then in the future, unspecified date, we expect to have somebody from the Internet Society talk about ISOC's role. I could come back and talk about the IOAG that I just mentioned a few minutes ago. We've recently formulated a committee to study LunaNet governance, and we can issue a progress report on that. Dave Israel, also of NASA at Goddard, can talk about our work on implementing LunaNet from NASA's perspective, followed by David Gomez-Otero, who's working closely with us right now on ESA's implementation of LunaNet through their Moonlight program. And farther in the future, we may talk about position, navigation, and timing for exploration, because we are folding PNT services into the definition of LunaNet. So in the future, we expect that LunaNet and interplanetary networking is not just networking in the sense of traditional network layer services, but communications at the link layer service, surface, and PNT services, as well as some science services that we can foresee coming. So the future is bright, and we'll hope to see you in the future. And you can link to our recordings on our IPNSIG website as well. So if you're already a member, thank you for being a member of IPNSIG. If you're not a member, it's time to join the club. Over 900 members have already signed up today. So you can join us by sending a message to membership@ipnsig.org. And I think our participation graphic on the left shows a very interesting statistic. This is a very broad, internationally based interest group, and we hope to see that continue. So with that, we want to thank you, and hope you take our short survey. You can look at the QR code there while it's flashing. Go to the SurveyMonkey site, and if you've been captured by our Master of Ceremonies or operating behind the scenes there, you may receive a survey to point you in the right direction. So with that, I believe we're done, and we can conclude for the evening. Thank you, everybody, for attending. Good night.
Thank you all.
Thanks so much, Jim. Good job.